Alright, next type of AP reaction we have to be able to do is one where water is considered a reactant. There's three different types of AP reactions with water. One is where you have a metal or a metal hydride dropped in water. So a metal is going to be like sodium. A metal hydride would be a metal with hydrogen on the end of it, like sodium hydride would be NaH. So that's what a hydride is. You have the H on the end of it. So you just take the metal and whatever the charge is on the metal, like for example sodium's +1, you'd add 1H. Calcium hydride would be CaH2. That would be one case where you drop it in water. Another case is a metal oxide. What is a metal oxide? It's a metal bonded to an oxygen. So for example, magnesium oxide would be MgO. Calcium oxide would be CaO. So that's what a metal oxide is, and that's dropped in water. Last one is a non-metal oxide dropped in water. So that would be something like SO2, SO3. The front is a nonmetal with an oxide on the back end. So those are the three kinds, a quick overview. Now, when we talk about the first one is a pure metal or a metal hydride will produce a base and a hydrogen gas. So the base is always going to be a strong base, so it's going to be shown apart. You have to show both ions, and you always will produce hydrogen gas. So if you look at the example here, sodium metal. How do you show sodium metal? As Na. Water, obviously, you're just going to write as H2O. What are you going to produce on the other side? The base. NaOH is a strong base, so you're going to write Na plus, OH minus, and then you show it as H2 gas, or just write H2. Calcium metal is added to distill water. What do? I write calcium, I write water, I show the base. Calcium hydroxide is one of the only ones that we consider to be slightly soluble, so you can either show it together or apart. You can get away with either one on the AP exam. They'll give you points for both. And finally, H2 gas, and you're done. You're ready to rock and roll. You want to make sure that you balance it. That's not balanced, but you go through and make sure you balance it. That's one case. The next case is a metal oxide. A metal oxide, when you drop it in water, will only produce a base. That's it. So for example, potassium oxide, K2OH. You just write it as K2OH. It's added to water, so I write H2O. What do you get on the other side? You get the base, K plus, OH minus. You show it apart because it's a strong base. So anytime you drop a metal oxide, they're also called basic anhydrides. You drop them in water, they produce a basic solution. Barium oxide, how would you show it? BaO plus water, and on the other side you get the base, Ba2 plus, OH minus. That's the second kind of water as a reactant. Third one is the toughest one. Non-metal oxides, when you drop them in water, they produce acids in water. So a non-metal oxide is called an acidic anhydride because it produces an acid in water. The acids kind of involve a little bit of rote memory. For example, solid dinitrogen pentoxide. Dinitrogen pentoxide is N2O5, water. You're going to produce nitric acid on that side. You're going to show nitric acid as a part because it is a strong acid. So it's H plus and O3 minus. Carbon dioxide gas. You show carbon dioxide there, bubble through water. You have water as a reactant. You're going to put together an acid. You have to just think of common forms of acids you remember. It's either a little memorization or a little kind of guessing. So in this case, you're going to produce carbonic acid, which is going to be H2CO3. As I go through some of the other examples, it'll seem a little bit more familiar. Look right here. Dinitrogen pentoxide. So we're going to start with some examples. Dinitrogen pentoxide is going to be N2O5 plus water. I write water there. Arrow, I am going to get nitric acid out of this. I show nitric acid as H plus NO3 minus because it's a strong acid. Solid sodium hydride. Hydride or just a metal produces a base and H2 gas. So I show sodium hydride as NaH plus water. What am I getting on the other side? I'm going to get a base. Na plus OH minus plus H2 gas. Sulfur trioxide gas. Well, sulfur trioxide is SO3 plus water. Remember, water is a reactant. In this case, SO3 produces H plus HSO4 minus. It produces sulfuric acid. which is a strong acid, therefore you have to show it ionized with the H plus breaking off of it. That's a tough one. You got to kind of know that one. Cesium oxide. It's a metal hydride. So what am I going to get? CS 2O is cesium hydroxide plus, I'm going to put with water. And what am I going to get in the end? CS plus 1 plus OH minus, a strong base. Sulfur dioxide gas. Sulfur dioxide is going to be SO2 plus water. Well, when I add SO2 in water, I don't get sulfuric acid. I get sulfurous acid, which is a weak acid, which I can show it as all together. H2SO3 is a weak acid, so you see on this example it's shown together. Next one, small piece of calcium metal. If it's just a metal, you just show it as Ca reacting with water, you're going to produce two things, H2 gas, and you're going to produce CaOH2 as a base. You can show it together or apart for that one. Strontium oxide. Strontium oxide is going to be SRO plus water. It is a metal oxide, which means the only thing it's going to produce is a base. So it's going to be SR2 plus OH minus. Of course, I have to balance these. I've been balancing these, but you guys can go back through and that. I've already taught balancing. Calcium oxide, CaO plus distilled water is going to be water, just H2O. What am I going to get on the other side? I am going to get CaOH2, or I could show it apart. That one I can do either way. Solid sodium oxide, NaO plus water. What am I going to get on the other side? I am going to get a base, Na plus OH minus. Last one is sulfur dioxide gas. We've done this before. SO2 plus water. I'm going to get H2SO3. Some common things you want to kind of remember is this. SO3, when reacted with water, the end product is going to be sulfuric acid ionized. These are ones I talk about you got to kind of know. If you drop SO2 in water, you're going to get H2SO3, sulfurous acid, the weak version. If I drop in N2O5, I'm going to get nitric acid, which is H plus NO3 minus. If I drop in NO2, I'm going to end up with HNO2, weak acid, and then finally P5, actually P4, either P4O10. You're going to drop that in water, you're going to get phosphoric acid, which is H3PO4. These are kind of ones that the non-metal oxides, when you drop them in the acids you get, are kind of, you have to know by memorization. That's the only real way to do that one. And those are water as a reactants. There's three classes of them. Basically, you have a metal or a metal hydride dropped in water. You can produce two things, H2 gas and a base. Bam. Metal oxide, the only thing you're going to produce is a base. Non-metal oxide, you're only going to produce an acid. And those are what you want to keep in mind when you're doing these.